Have you ever wondered what's really going on inside all the smart technology we use every day? It can feel a little bit like magic, right? Well, today we're going to pull back the curtain on one of the most powerful and, let's be honest, mysterious pieces of that puzzle: artificial intelligence. We're going to demystify neural networks and figure out how these digital brains actually learn.
So here's the plan. First, we'll look at the AI that's already all around us. Then, we'll explore the incredible biological model that inspired it all, the human brain. After that, we'll peek inside the digital mind itself, see how it learns from its mistakes, and finally, we'll wrap up with why this is such a huge deal.
All right, let's just dive right in. Section 1, AI that's all around. Because you might not realize it, but you're probably interacting with this stuff dozens of times a day.
I mean, think about it for a second. How does your phone unlock just by seeing your face? How can it possibly pick you out of the billions of faces on the planet? What's the secret?
Well, the answer to that question, and the magic behind so many other things we just take for granted now, is neural networks. They are the engines running behind the scenes. They're the reason your streaming service just knows you're going to love that new sci-fi show. They're why your email inbox isn't completely buried in spam. They're how your map app can see a traffic jam forming before you're even in it. They are truly the invisible intelligence of our modern world.
Okay, so we know where they are, but what are they really? Well, believe it or not, this incredibly futuristic tech is actually based on a surprisingly natural and, honestly, beautiful model. Which brings us to our second section, inspired by the brain.
On the left, you've got a biological neuron, the kind that's in your head right now. It gets signals from its neighbors, thinks about them for a split second, and then sends a new signal out. And on the right, that's its digital twin, the artificial neuron, or what we call a node. It does basically the exact same thing. It gets some data, does a quick calculation, and passes a result along. Super simple, right?
And here's the big secret. One of these artificial neurons on its own, it's not very smart at all. But the magic, the real genius, happens when you connect millions or even billions of them together in a network. That's where the intelligence comes from. It's not the individual part, it's the power of the whole system.
Okay, so let's pop the hood and actually see what one of these networks looks like. This is Section 3, Inside the Digital Mind.
So first up, we've got the neuron, or node, which we just talked about. The best way to think about it is like a single Lego brick. It's the most basic, fundamental building block of this huge, complex thing we're about to build.
Now, you don't just have a big pile of Lego bricks, right? You organize them. In a neural network, we do that with layers. You've got an input layer that takes in the raw information, an output layer that gives you the final answer. And sandwiched in between, you have what are called hidden layers that do all the really heavy lifting. And they're only called hidden because we don't directly see their work. They're just the engine humming away in the middle.
So how do all these neurons in all these layers talk to each other? Well, through connections, and each connection has something called a weight. Now, this is maybe the most important part of the whole system. Think of a weight like a volume knob or a dimmer switch. It controls how much influence one neuron has on the next one. Learning, for an AI, isn't about writing new code. It's about learning how to tune all of these little knobs perfectly.
So let's trace how this actually works. Let's say we show the network a picture of a cat. The input layer doesn't see a cat. It just sees a grid of pixels, raw data. But then, the first hidden layer looks at those pixels and might learn to spot simple things, like edges and basic lines. The next layer might take those edges and combine them into simple shapes, like a pointy ear or a whisker. And the layer after that combines those shapes into bigger ideas, like paws and a tail, until finally, the output layer puts it all together and makes a decision: yep, that's a cat.
So we have all the parts, but this is the big question. How does the network ever figure out which patterns mean cat in the first place? How does it learn to tune all those knobs on its own? Well, that brings us to Section 4, learning from mistakes.
The learning process is basically a giant loop of trial and error. It's actually really intuitive. First, you show it an example, a picture that you've labeled cat. The network processes it and makes a guess. Maybe it says, "Is that a dog?" Then it checks its work. It compares its guess, dog, to the right answer, cat, and realizes, oops, I was wrong. And here's the magic step. It then goes all the way back through the network and nudges every single one of those little weight knobs just a tiny bit to make it slightly more likely to guess cat next time it sees something similar. Now imagine doing that not once, but millions or even billions of times. That is how a network learns.
Which brings us to our last section, why this all matters.
We've gone from these super simple little neurons all the way to this complex learning loop. So, what's the big payoff?
Well, after all of that training, all that trial and error, what you get is pretty incredible. On tasks like recognizing objects in photos, a well-trained neural network can achieve over 99% accuracy. To put that in perspective, in some specific cases, that's even better than a human can do.
And that leads us to the single biggest takeaway here. For most of computing history, we told computers what to do with a strict set of rules. If this happens, then do that. But neural networks are a totally different game. You don't program them, you train them. They learn to find the important patterns in data all by themselves, which lets them solve problems we could never dream of writing rules for.
And that leaves us with a pretty mind-bending final thought. I mean, this technology is already doing everything from identifying cats in pictures to driving cars and helping to discover new medicines. It's already changing our world in massive ways. So the real question is, what on earth will they learn to do next?